What plans do I have for extending the procedure declaration note stuff? You work on a team of 20 people and issue tracking project management tools like Jira, which are separate to the code, are a pain. Maybe there's a way the language metaprogram can help. Okay, so my idea from early on that I haven't yet implemented, and again, people can send me to the mail alias what they think about this, is that, okay, so that we're clear what everyone's talking about, right? Let me go, or let me go to here, right? So here's the game that we work on all the time, and we have these annotations that we could put on things that are poorly formatted right now. I apologize for this. But what this actually looks like internally is just, it's a string that your metaprogram can parse, right? And that string can have things. So this says v4-7 is the string, and the metaprogram says, oh, those are version numbers, and that's when this field is valid. So you have complete choice over how to do this. And the nice thing about this is it's very simple to understand. Oh, you just get a string, right? The bad thing about just getting a string is the bad thing about every programming language that just gives you a string. It's just confined to a smaller area here, right? Like, what if you import somebody else's module and they use some strings on their data structures that collide with the strings that you use, and your metaprogram gets confused, and then you maybe have to, you could manually go in and carve out exceptions or something, but that's annoying, right? Strings are error prone, and you can make typos and all that kind of stuff. And so the idea that I had early on, and I would be interested to hear what people think about this, would be to have we would probably leave the strings for backward compatibility, at least for now, but to have a thing, maybe if you said at or something, right? Then what comes after that is actually a struct literal, right? And then what you get in the metaprogram is that struct literal, right? So you know the type of the struct and the values and all those things, right? And the good thing about it being a struct literal is that now namespace collisions are handled correctly with exactly the same amount of robustness as is present in the rest of the language, right? So if one module has a struct called thing and another module has a struct called thing and your main program has a struct called thing, then the thing that you get is the one that was in scope here or the one that you navigated to, right? And that is a very strongly typed version of notes. It is not in yet. I mean, in part because we didn't have struct literals and stuff. So it was kind of a messy thing to think about when we didn't have that. But that has sort of been vaguely on the roadmap, right? The second thing, though, is it's a little bit like, these are a little bit inconvenient in terms of just when the parser looks for them. Right now, they just go on declarations, which means anywhere in a declaration that you could find one, you could sort of put one in. They don't go on other kinds of statements or expressions, and they don't go on like other arbitrary directives at top level. You can't have a note by itself out in the void. And so that's probably a little bit inconvenient. Again, for our use case in building our software, it hasn't seemed to matter, but I could understand people wanting that. I think there's one other place. I think you can put them in here to put them on the struct type, I think. It's funny that I don't even know that because I never use it, but it's possible to put them on the actual struct, which is different from putting them down here on the declaration, because you could get to them from the type that way. Anyway, so yeah, making those better is vaguely on the list. I don't know what we're gonna do though. Do I see any places in the type system where things could be added to make robust parallel programming easier? I think a large part of that is, okay, I would like to do that. I'm not going to talk about far away unannounced features because when I do that, what happens is other people copy them for their stuff. There are some unannounced features that I have in mind, but also I think a lot of that can be handled from the metaprogram level. Okay, so one of the things I talked about in the earliest talks was having having syntactic constructs that would narrow down the namespace that you're allowed to access, right? And that would be a way of just ensuring that, like, oh, this little program that I have over here can't actually get to anything, right? Now, there are some other ways that I could think of to do that I'm not going to mention. But also, that is something that your metaprogram can do. Like, it could look at a file and look at where the identifiers go and say, is that an okay place to refer to or not, right? I think that would be very helpful. In terms of like making sure that you don't access global state that you're not supposed to. Other things, like, is there stuff we can do to help with, like, using mutexes correctly? I definitely think there is, but that discussion can go a lot of different ways. I would almost prefer to have a special topic discussion on that some other time, because it's a deep subject, actually. Any plans to move the temporary allocator to the context so we can change the way it works if we want to? That's a weird one, okay? I'm not sure what to think about that. Because I was torn when I implemented it, in the sense that part of the point of the temporary allocator is to be really fast. To be much faster than malloc, right? So, like, it doesn't have to synchronize with other threads. It doesn't have to worry about you ever being able to free anything. It just goes, right? It knows it has space available. It just goes. Also, it means you don't have to call through a function in direction to get the temporary allocator. Now, that said, the context is pretty much guaranteed to be in cache the whole time for the execution of your entire program, at least that part of the context. Of course, at user level, you could add something giant to the context if you wanted to, but that stuff, all that basic stuff, is packed together at the beginning of the context. So that was just sort of the trade-off I was facing at the time. That said, since then, I have changed the temporary allocator in ways that are theoretically a little bit slower, but that enhance usability, right? I mean, it's still tremendously faster than malloc, but like the original temporary allocator, if you went over the initial allocation boundary, it would just leak. It would just... I think it would just start calling malloc and leak or whatever, whereas now it actually has overflow pages that it cleans up and all that. So you can actually overflow a tremendous amount from temporary storage and it's fine. So it's actually a little bit less simple of a data structure than it was originally. Like, it was originally supposed to be like dead simple, and now it's less dead simple. But that seemed like the right thing to do in terms of making it usable for most people's programs, right? So I could see it morphing further is all that I could say there. So moving it to the context. Is an interesting question. I mean, yeah, like there might be a speed hit there. It might not be a meaningful speed hit, again, because that function pointer is always going to be in cache. At least I could say that now, but more things we add to the context, the more cache we use, right? So there's that too. Um, mm, mm. Yeah, I mean, I think it also depends on use case. Like, how are you going to use it and that sort of stuff. Like, we would definitely have to think about it. There's already a little bit in the way of interactions that I had to think about pretty carefully in terms of um, allocators being overridden. Um, like core libraries avoiding using temporary storage or avoiding using context.allocator because they don't know when they're going to run and so forth. So there just tend to be things to think about. But yeah, that's the thing we could talk about. Threading is currently based on function calls. Is there no interest in tying thread functionality more tightly to the language and makes it easier and more natural? No, I would say no right now. And the reason is because I don't have any ideas about how to do that are good, that are also different from what other languages are doing, that I don't think are the future. Like all these languages have different kinds of threading primitives, and most of them, like with a lot of things, most of them make it easier to solve the easy problem and don't help with the hard problem, right? And I want to help with the hard problem. The hard problem is, how do you actually use all the cores on your computer, all right? And the problem is if you do something like coroutines, right? Or, I don't know, like the kinds of things that some languages have, those constructs are not high performance constructs. They're not, so whenever people talk about concurrency, right? This is a concurrency primitive. They're kind of, I mean, on the one hand, concurrency is a computer science word with a technical definition, right? On the other hand, it can very easily serve as a way to avoid saying parallelism, right? And parallelism is actually what you care about in all cases. Even if you're doing something like, oh, I want to make a web application, it's on the server and it's concurrently calling out to other things that concurrently call out to other things and so forth. Well, you want those things to overlap